Welcome to Module 6. At this point, you are in it to win it, and we are going to talk about storage. I know, storage doesn't sound too exciting, but I think you are going to learn some great stuff here that will help you in your career. So we're going to look at storage options, disk management. We're going to look at RAID, which is something you may have seen in a previous class or two, but we're going to go a little bit more in depth, and we're going to use storage spaces, which is something you probably have not seen, and we'll do that, of course, in Server 2016. We'll look at multipath I/O, and we'll look at some backup. So lots of great stuff for Module 6. So Server 2016 has a lot of storage options. Supports two essential disk storage types. One of those is the basic disk and one is the dynamic disk. Now this has been true all the way back to earlier versions of Windows Server. Excuse me. However, not everyone has embraced the dynamic disk, and that's because it has its advantages but also has some disadvantages. So the basic disk is a traditional disk, and by default when you format a disk, it is going to be a basic disk in the server. You can create primary partitions, extended partitions, and logical drives. Dynamic disks does not use traditional partitioning. It's a lot more flexible. There's no restriction on the number of volumes, at least none that you'll reach anyway. Partitioning that allocates a group of tracks and sectors such as NTFS. NTFS is our standard formatting process. And of course, formatting itself creates a table containing file and folder information. So what that means is when you format a disk, you are creating a list of pointers. So you create the data, but you've got to be able to find that data, so it creates a table that points to where the data is. So you need to format that in order to get that table to be created so the operating system can work. A volume is a logical designation of disk storage. So basically that means that you can take one disk and create a volume. You can take multiple disks and create a volume. And using storage spaces, which we'll talk about a little bit later, is one of the ways that you can do that. So let's go ahead and move on here to basic disks can be set up using multiple different types of RAID. So Windows Server 2016 using basic disks allows you to do something called disk striping, which is RAID level 0. So that's another way of, sometimes we refer to this as a JBOD or just a bunch of disks, where you just take hard disks and then you stripe them with the data. So if you say you had a 1 gigabyte file, it will take a little bit of each of 3 disks. Let's say if you had 3 disks in your RAID 0, and it'll spread that file across the 3 disks. So now instead of one little needle going back and forth looking for the data, you now have 3. So that makes it much faster to access that data, which is why we do it. However, there's no redundancy in level 0 RAID. Even though it's called a redundant array of inexpensive disks, this is the one level that doesn't actually provide any redundancy. So you've got disk mirroring. That is where the data is written to one disk and then mirrored to another disk. Extremely slow, but very inexpensive. You only need 2 disks to make disk mirroring work, but you can use more if you want. Disk striping with parity. So disk striping with parity, RAID level 5, is very similar to RAID level 0, except for it has a parity bit at the end. So instead of just 8 bits, it actually has 9 bits. So the 9th bit is going to be for parity. So in case any one drive fails, it uses some mathematical wizardry in order to take that parity bit and continue working with a missing disk. So no matter how many disks you have, whether you have 3, which is the minimum, 5, 10, 20 disks, RAID 5 will give you 1 failure disk to recover. So if 1 disk fails, everything's good. 2 disks or more fail, RAID 5 won't help you. RAID 6, however, will allow you to have 2 disks that will fail. And so you can get some additional protection that way. So as I mentioned earlier, RAID stands for Redundant Array of Inexpensive Disks. Disk striping, as I also mentioned, spreads the data over multiple disks or volumes, and then mirroring just mirrors the data from one to another. So by default in the old days, and I'm talking probably 5 years or more, old as far as computers go, we would format our drives as, we would partition our drives as MBR, but we also had the option for GPT. And we typically used MBR, master boot record, because it allowed us to create partitions up to 2 terabytes. But now we're starting to create partitions much larger than that. So now our default in 2016 is going to be GPT, because that allows us to create much, much larger partitions. So we use the GPT. It's called the Global Unique Identifier Partition Table. GUID partition table is another way of saying it as well. It also requires that instead of using a BIOS, you're going to use the UEFI. So the UEFI, as it stands for Unified Extensible Firmware Interface, basically works the same as a BIOS did, but it has a lot more enhanced features, and it also gives the advantage of using a mouse, which you couldn't do in a BIOS. So that is part of the partitioning process. So a lot of people do get confused between partitioning and formatting. Partitioning is what you do first. That's where you either create it as an MBR or a GPT, and then after that you format the various different drives into smaller chunks, or take multiple drives and create one larger one. GPT partition, as I said, can go much bigger than 2 terabytes, can go to 18 exabytes. You might see that on a test now and then. It can hold up to 128 partitions. And if you want, you can convert an MBR disk to a GPT. According to the directions in the book, you can go back and forth between the two. However, if you created more than a 2 terabyte partition in GPT, you cannot go back to MBR. So why would you even care about going from GPT back to MBR? Well, that's because certain programs, certain operating systems, they just work better with one or the other. But nowadays, almost all of them work better with GPT. Primary and extended partitions on an MBR disk. You can create a primary partition, which is what you boot the operating system to. And you can also create extended partitions as well. So if you want to have a C drive and a D drive and an E drive, etc., then you can certainly do that with an MBR. And you can also, of course, do it with GPT. Volume and stripe sets. So in Server 2016, they no longer really call it RAID 0, RAID 1, RAID 5. However, they call them volume sets and stripe sets, or also with parity. So you'll see that when you get into creating your parity drives. So Windows Server 2016 provides backward compatibility with basic disk volume and stripe sets that you used to do with previous legacy Windows Server operating systems. However, it's recommended you convert your basic disks to dynamic disks in order to implement new types of multi-disk volumes that were not previously available. So a dynamic disk does not use traditional partitioning. It makes it possible to set up a large number of volumes on a disk. So remember, a volume is different than just the disk itself, the disk partitioning. So the volume is going to be made up either of many disks, or it's going to be broken into smaller chunks of one disk. It's anything that you want, anything in between, or any combination. Dynamic disks do support RAID levels 0, 1, and 5, but again, they don't call it that. They call it striping with parity instead of RAID level 5, for example. On dynamic disks, the volume that contains the Windows folder of the system files is called the boot volume, and the volume that contains the files used to boot the computer is called the system volume. So the terminology changes just a little bit when you go to dynamic disks. Simple volume is a portion of a disk or an entire disk that is set up as a dynamic disk. So simple volume is what you create by default. A spanned volume is when you span it across many disks, and you can go from 2 to 32 dynamic disks. So if you want to use storage spaces to create a spanned volume, you're going to have to convert them to dynamic disks. The advantage is you can more easily manage several small disks or maximize the use of scattered pockets as well. So lots of flexibility when you do that. Striped volumes, as we mentioned earlier, is referred to as RAID 0 in previous situations, but in this Server 2016 situation, they refer to it as a striped volume. So it requires at least 2 disks. as many as 32 if you'd like. It does not have to be the same size drives. You could use a 500 gigabyte, a 1 terabyte, a 4 terabyte, put them all together and create a volume. So whereas traditional RAID 0 required that you had to have the same size drives in, for the entire thing. But you don't need to do that with this in storage spaces. Shrinking volumes. Windows Server 2016 comes with the ability to shrink a volume, basic or dynamic disk. However, if you do format your hard drives as REFS, REFS does not give you that ability. So you have to format the drives as NTFS. And that'll make more sense in the lab when you see the mini videos that show you what all this means. So if you are interested in shrinking a volume, you can do that. You can see the before and after. It can be a little bit confusing. So it shows the total size before shrink, size available, shrink space. So what this means is that it's saying, hey, you've got a certain amount of data on here, so I'm not going to let you shrink it beyond that point or we're going to lose some of that data. So it's taking you to the second option here where it says size of available shrink space. It's taking you to the absolute smallest amount that you can shrink it to. I don't recommend that you do that because then you'll basically be out of space even though you won't lose any data. So you probably want to be somewhere in between. And that's where you enter the amount of space to shrink. And that's the only spot that you can enter that information. Then it'll recalculate and it'll tell you what the total size will be after you shrink it based on what you type into that box. So why would you want to shrink a partition? Well, sometimes we want to shrink a partition because we want to create a separate drive letter to maybe install something different. Something that should not be on the same drive as the operating system. For instance, the paging file. The paging file shouldn't be on the same partition as the operating system. It's less efficient, so you could move it off to a different partition and make it more efficient. And there's other reasons as well. We've got 2016 comes with some tools to diagnose disk problems. You have the disk optimizer, disk check, and check disk. And check disk is a command that we do from the command line. You can have it done while it's in Windows on any non-operating system partitions, or you could also have it done at boot up, so it does it even before the C drive comes online and the operating system loads. So check disk is something that we've used for decades in order to save us from all kinds of hardware problems that occasionally happen. It won't fix a drive that has completely failed, but it will fix a drive that's functional but screwed up. So that's why we use check disk. The disk optimizer, when you save a file to a disk, Windows 2016 saves a file to the first area of available space. The file may not be saved in a contiguous area of free space. So basically that means that if you have a free spot, it's going to stick part of that file in the free spot and part of that file in another spot of the hard drive. And that fragments the drive, which makes it very slow. So Windows automatically will defragment when it has time, when it has processes in the background. Whereas before, in previous versions of Windows, back prior to, say, 2008, you would have to manually go in and defragment the hard drives. So that does give you that advantage. Disk Check tool allows you to scan your drive for bad sectors, which is exactly what Check Disk does. It's just a graphical version of Check Disk. So as I mentioned before, Check Disk is a command line. And also Check Disk does have a lot more options than the Disk Check program as well. Fault tolerance, that is a term you should know. It is the ability of a system to recover gracefully from hardware or software failure. As I mentioned earlier, RAID 5 is a great example. Even RAID 1, where one drive fails, the other drive continues to work. Fault tolerance data is written to more than one drive. So basically, that is part of the requirement for fault tolerance to work. So we talked about RAID 0, talked about RAID 1, but guess what? There's a lot of other levels of RAID. Now, you don't use them in Windows 2016, but you may use them in a hardware RAID controller. So what we've been talking about up until now is software RAID. Software RAID is slower. Yes, it is redundant. It does work just as well as far as it does work. But speed-wise, it is way slower. So you're going to have the problem of software RAID, so I don't recommend that you even use the server RAID that's built into Windows unless you don't have a hardware option. So if you do have a hardware option, you'll have a lot more RAID levels to choose from. Besides 0 and 1, you'll have RAID level 2 in some cases, use an array of disks where the data is striped across all disks in the array. Then you have RAID 3 as well. So here is what one type of RAID looks like: disk mirroring. You have your primary drive, and then all your data is mirrored to your secondary drive, or your mirrored drive. And you have a controller that does that, or in this case, if you use storage spaces, then Windows, the operating system itself, does it. And again, the operating system is going to do it much more slowly than a controller card, or a discrete card is what we sometimes call it. Disk duplexing. Another type of thing that you should be aware of, but you're probably never going to do, and that is where you have two RAID 1 cards, and the duplexing runs faster than the single RAID card that I just showed in the previous picture. So two RAID cards doing the duplexing, and it costs more money. Rarely does anybody do that. Then you have RAID level 4, stripes data and stores error correcting information on all the drives with an added feature of performing checksum verification. For whatever reason, that one never really took off. RAID 5, however, did. There's also other RAIDs as well as RAID 10, which is fairly popular, and RAID 50 as well. So you may come across those in certain hardware RAID card situations, but you won't within Windows. So if you did want to use RAID level 0, that's if you don't necessarily have data that you don't mind losing. So I mean, if you had, say, a game server, for instance, you want it to run as fast as possible, but if it crashes and burns, you could always reload everything. So that's a great example of why you'd want to use RAID level 0. However, you would not want to use that for your server that's serving up clients, because you want to have some redundancy that RAID 0 doesn't have. All right, so we've talked enough about the RAID. Fault tolerance, of course, is better with RAID 5. Let's see, let's go on to software RAID implementation fault tolerance through the operating system. So as I mentioned before, Windows Server 2016 can do the RAID, or you can have the hardware do the RAID. So the interesting thing about hardware RAID is, besides being faster, is Microsoft isn't even aware of it. It just sees a big hard drive. It doesn't see that RAID is even being done. Whereas if you do software RAID through the operating system, of course it knows everything that it is that you're doing. Storage spaces is where you set up your RAID, whether you're doing RAID 5 with the striping with parity, or doing the mirroring, and you can even do what's equivalent to RAID 0 all through storage spaces. You can use different types of drives: SATA drives, SSD, non-volatile memory, which is a new thing, USB drives, and SCSI drives as well, even iSCSI drives. So iSCSI is all done through the network, whereas SCSI is an old-fashioned technology that we rarely use anymore. So nice thing about using storage spaces is it does know the difference between a solid-state drive and a SATA drive. And it will recognize that the solid-state drive is faster than the SATA or some of the other options. And so you can set it up so where caching is done, or even the paging file is done on the SSD drives, and the storage is done on the slower drives. So Storage Spaces has made some nice advances there that I have not seen in hardware RAID. So as I mentioned, iSCSI is available. It's done through a network cable, and there you have to use the iSCSI initiator. And if you want to turn a server into an iSCSI target, then you can get the storage version of Windows Server 2016. It's a lot cheaper, or you could use the standard or data center one, but it would be a lot of extra money to do the same thing. So tiered storage spaces, that's where I was mentioning earlier about slow and fast drive. You just have to set up the tiers so the SSD drives do the things that require the extra speed, and the slower drives do the storage portion. You also have the option for thin or fixed storage. So what thin does is you can say, I have a 3 terabyte partition, but I'm creating a thin provisioned setup. So basically what that means is that Windows is going to keep it a small amount, and then as you add more data, it expands all the way up to that 3 terabytes. Whereas a fixed amount is going to use the 3 terabytes right away. It's much faster, but it's possible you may end up needing that storage for something else, which may make thin a better way to go. So you could, even though you have 3 terabytes earmarked, you're not using it yet because it's only going to use it as it needs it. The new storage pool is created through Server Manager, and the steps of that are on 309 and also in the mini videos. We have software-defined storage, refers to managing data storage with software that's independent of the actual storage hardware. That goes beyond the scope of this class, but it is something you should be aware of. Server 2016 uses SMB version 3. That, by the way, is also something that Macintosh likes to use as well, so you can connect to SMB v3 shares from Mac and from Linux and Unix. Storage spaces are targeted for use with virtual machines operating through Hyper-V and for clustered virtual machines as well. So you actually can create special types of drives specific to work with virtual machines or clustered storage. Cluster can have up to 240 disks and up to 12 nodes within the storage spaces direct. And there's 2 ways to deploy storage through hyper-converged and through disaggregated Hyper-V clusters. So again, beyond this class, but still something you should be aware of. You might see a quiz question about that. Multipath I/O, typically I use this for iSCSI a lot of times, where I'll have multiple different network cables all connected to the same storage. So if one network cable goes down, or network card goes down, either way, then my other ones will work. But you have to install the Multipath I/O feature in order to get that to work. Disk backup. Windows Server backup is included in Windows Server, and you'll be doing that in an upcoming lab. However, you do have to install that particular feature to get that to work. It's the only option where you see it show up in the Tools menu, but when you open it, it says, hey, you have to install it before it'll work, which is really kind of funny. You can back up everything or specific files, folders, or applications using Windows Server 2016. You can also do it through command line if you want, and you can back it up to many different types of media. The tool only backs up NTFS volumes, so if you have FAT32 volumes, you will not be able to use the Windows 2016 Server backup tool. You might have to use a third-party program, and the tool does not back up to tape anymore, so that's something that has been dropped. You can do a full backup, an incremental backup, or a custom backup, and also in the lab that we do the backups, you'll also see the option for what's called a differential backup and what that means, or the difference between the two. Now, you can't do a differential backup in Server 2016, but third-party programs do, so you need to be aware of what that means, so you can choose which type will work best for you. You also have the ability to schedule Windows Server backup, so you can say what day, what time, and how often. And this is what the scheduler looks like. And the Windows Server Backup tool allows you to recover any one of the things that you see in the list here. All right, so we cover lots of different things when it comes to disks and backups. And now we're going to talk about network services. So we're going to install, we're going to configure, we're going to troubleshoot things like DNS, DHCP. We're going to talk about the IP address management tool, something that we do in other classes, but something you should be aware of for quiz questions, and NIC teaming as well. So some of these things we'll be doing in our labs, and some of these things you'll just be learning about the concepts of them in this one and doing them in upcoming classes. So DNS is definitely something that you've done. You've done that in Active Directory. When you installed Active Directory, it comes as part of Active Directory. However, you can install DNS separately on a non-Active Directory domain controller server if you choose to. And some people do choose to have additional DNS servers for redundancy. So DNS servers basically just translate names to IP addresses. So if you're trying to go to a particular computer name, the DNS database basically says, hey, I know where that is by IP address. So you don't have to remember the IP addresses, which is much more difficult for us as humans to do. The computer can translate that for you. It can also go in reverse direction as well. It can go from IP addresses back to names. It's installed as a server role, and after you install it, you'll need to configure it, such as adding DNS zones. Let's see, this is what it looks like to install DNS as a role, and again, it automatically happened when you installed Active Directory, but if you don't do that, then this is the manual way of doing it. DNS name resolution is enabled through the use of tables of information. You could also refer to that as a type of database. Tables are associated with partitions in a DNS server that are called zones. And then each zone houses tables of different types of resource records. So you will see this in some of the labs, what DNS looks like. We're using IP version 4, but there's also IP version 6 out there. 4 uses what's called a host record. So if you create a record, say for DCO1, DCO1 is pointing to 192.168.0.1. Well, that is a host record. DCO1 points to this IP address. That's a host record. It's also referred to as an A record. IPv6 uses these quadruple A resource records, but basically they're the same thing. When you have a domain controller, you also are going to see some additional records for the domain controllers. You're going to see some DC records, SOA for start of authority, for who's in charge, things LDAP records, so we know where which servers are domain controllers. You must enter the records of other hosts or configure DHCP. Now, what DHCP does is it automatically assigns an IP address to you when you first boot up your computer if there's a DHCP server on the network. And then it registers whatever IP address it gives it into the DNS manager. So if your client computer gets an IP address automatically from the DHCP server, DHCP says, hey, the client computer is at this IP address. So if you need to reach it, here's where it is. So DHCP and DNS work together. And as I mentioned before, you can do a reverse lookup as well. Reverse lookup helps you find the name servers themselves. It's used a little bit less often, but sometimes used for troubleshooting. Microsoft DNS is also called dynamic DNS because the computers automatically register their IP addresses when they get an IP address through DHCP, as I mentioned earlier. After configuring DNS, always make sure that it is configured to use, although it says SU here, the DNS Dynamic Update Protocol. You don't actually have to do anything here, it just happens automatically. You can manually turn that off, however. So if you go into the DNS manager on a domain controller, you're going to see the default zones that are created are Active Directory integrated. Basically what that means is if you have 2 domain controllers, DCO1, DCO2, when you make a change to a record on one server, it automatically uses Active Directory to copy that change to the other server. If it's not a domain controller, it doesn't work that way. You have to set up a manual replication. So you have a primary DNS server and a secondary DNS server. That's if you choose, again, this is not active. If we say we have 2 DNS servers that are not Active Directory. The primary DNS server is the only server that is allowed to make changes. The secondary server keeps a read-only copy of it. So why would you even want to have a secondary DNS zone or a DNS server? Well, that's because if you have a remote office where you know changes are not really being made to that office, but you want them to have a local copy of DNS so they can resolve names more quickly instead of going across a slow VPN tunnel. So you can create a read-only copy of that zone onto another DNS server. There's Windows Server and Windows Client absolutely require DNS to work correctly. Without DNS, you can't get out to the internet, can't get access to resources. It's super important to have DNS working properly. And what I find is 95% of all slowness, all connectivity problems are related to DNS issues. So this is something that if you learn well, you will be a very valuable IT administrator. A third type of zone is called a stub zone. That's used on occasion in some remote offices instead of a secondary zone. So you're either going to use a secondary or a stub zone. Stub zone has even less data on it than the secondary. It basically just redirects you to where the actual DNS server is, rather than keeping a copy of it like the secondary one does. So rarely do we ever have a use for a stub zone. Common to designate one DNS server to forward the resolution request to a specific domain DNS server. It's very similar to, let's say that we have two companies in one office, and the web servers are being hosted in the same office, but one is in one side of the building and one is in the other. So company A wants to go to, maybe somebody in company A wants to go to the website for company B. Well, typically, if it's not local to the network, it's going to go out to the internet. Well, that's not going to work because we need to get to company B on the other side of the office. So you can do what's called DNS forwarding. You can create conditional forwarders that basically forward to specific domains or to all domains. So the requests come into the local DNS server, and the DNS server says, hey, I don't have that, but I know who does. Either sends it out to the internet, or a conditional forwarder sends it over to the other side of the office. So you can take several steps to troubleshoot DNS, such as restarting the DNS server or DNS client services. Of course, look at the log files. That will give you a really good idea. DNS does break a lot, and so it is something that you need to constantly troubleshoot. DHCP, as we mentioned earlier, it's Dynamic Host Configuration Protocol, and it automatically assigns an IP address to a computer. Now, in our case, we are physically, statically setting IP addresses to our client and our computers. But in upcoming classes, you will have the opportunity to set up a DHCP server to automatically assign those for you. You can also reserve an IP address or exclude an IP address or a range of IPs from DHCP in case you have static IPs you don't want the DHCP server to override on your static. Because if you have two IP addresses that are the same on the network, then you have all kinds of problems. Errors pop up, things work really slowly for everybody. So you've got to make sure DHCP is set up correctly. You can also set up redundancy for DHCPs. You can set up a second DHCP server. You can cluster DHCP servers as well. So if one DHCP server goes down, then the other one can continue running. We create a scope when we create a DHCP server. It basically says, here's the range of IP addresses you can use, here's the DNS server, and here is your gateway or router out to the internet. You do need to authorize a DHCP server, otherwise Windows will not use it, and that's because if you have more than one DHCP server that gives out the same IP addresses, it can cause problems. So let's say you authorize a DHCP server on your Windows server and somebody adds an additional DHCP server on some other device like a router or a firewall. What Windows will do is it will automatically stop serving out IP addresses and let that other rogue DHCP server feed out instead to avoid having duplicate IPs. So it does have a lot of intelligence to it. All right, so we covered a lot of things. We covered DHCP, DNS, and of course we covered storage as well. So lots of good things in Module 6. So go ahead and get to the lab. If you have any issues, you know where to find me. You can call me, you can email me, and I'll be happy to help you. So let's move on to the lab in Module 6, and then I'll see you in Module 7.